In this demonstration, I'm going to present Shigong Media's very own contents in interactive and computer graphic just for the educational purpose. This is a layout of the electromagnetic experiment that's been going on in a school. So we have a battery here, and the current flows on the side, and we have a switch, and we have a field, and we have a magnet here, so we can represent how the electromagnetic actually works. So the battery can be switched in minus and plus sides, and if you click the switch, the current flows and the coil is rotating. So we have a stronger coil which will have accelerating the current flows, and we have a magnet which will change the direction of the rotations. We also have a stronger magnet here, so the current flows are faster and the coils are rotating faster. We also have battery that's more powerful than the one battery, so the current flows are actually higher and more stronger, which will result in the coil rotating even faster. So these interactive tools are very effective in learning of electromagnetic and the concept of the electromagnetic. In this demonstration, I'm going to represent the sundial and the virtual environment of the sundial. So when I scroll the mouse, scroll in, the sundial will actually close up and it will be zoom in. And when I scroll out, the sundial will zoom out also. And if I click it, I can rotate the sundial and view the whole 360 degrees of the sundial. When I clicked to see the scale, this screen represents the scale of the sundial. And on horizontal sides, we have 24 different seasons in one year. And also on the vertical sides, we have a time from 5 a.m. to 7 p.m. of the day. In this window, this represents how actually the sundial is working according to the altitude and the season of the sun. So during the summer time, the altitude of the sun is very high, as you can see here, and the shade of the sundial is on the very bottom, which represents the season is summer. And during the winter time, you can see the shade is very on the top of the horizontal scale, and the altitude of the sun is lower than the summertime. In this experiment, students can learn how their ancestor can read time according to the sun rise and fall, and also the seasonal change according to the sun rise and fall. In this demonstration, we show how traditional Korean houses are laid out and some features within the traditional Korean houses. So in here, we can see the layout and different section of our Korean traditional houses. If I move to the house, it actually shows how you would actually move into the house. And I'm going to show you the traditional Korean way of heating during the winter time. So when they fire in the kitchen, the warm air will flow underneath in the room, and it goes out to the chimney. And if they have a bigger fire, it'll get warmer. And I'm going to move to a separate house just for them to pray and remember of their ancestor. And in this section, we have a voiceover recording, so the students can hear what this specific house is stands for. In this demonstration, I'm going to show you the concept of lever and how we apply this concept in the educational and interactive way to students. So we have a pivot point here, and we can drag it to make it closer to the object or drag it to make it farther to the object. And we have 3 different sizes of the weight to weigh on here, so we can lift the rock. And we have a bird here which is trapped underneath the rock, and we're trying to save it. With 3 person, I failed to save the bird, and when I moved the pivot points closer to the object, even with 1 person, I succeed to save the bird. By putting hard physics concept of lever in this easy and entertaining interactive way, students can easily learn and effectively learn the concept of the lever.